Okay, so this is an alternate solution to the example that I went over at the end of the launch at an angle video. In that video, I focused on the total time first. So I basically went from the ground to the ground, and I found the time at this point, right? So I found the total time first, and then once I had the total time, the time to get to the maximum height is just the total time divided by 2. So what I want to do in this video is show how we can find the max height info and then bring it back to the total, okay? So in the previous video, I did this first, and then I went here, but in this video, I want to do these two first, and then I'll go to the total time second, okay? But again, the first thing you have to do, break down the vector, right? Break down the initial velocity vector, and then write the position. So this is gonna be a little bit different. So we can write the position vectors, okay? Oh, we substituted in 9.8 for our A, right? So we're just gonna call this 4.9. Okay. Now, if I treat this point mathematically as the vertex, okay, I can do negative b over 2a. But when I do that, what I actually do is I find that my time to get to the max height, I'll call it t sub m, is just going to be negative initial velocity in the y direction over negative 9.8, okay? Because remember, for the vertex, it's going to be negative b over 2a. Well, remember, in physics, our x is t. In this case, my b is negative v0y. And then 2 times negative 4.9 is 9.8. Where does that version of the formula actually come from? It comes from here. Vy equals v0y plus at, or excuse me, let's put in our 9.8, right? It becomes 9.8 minus 9.8t, where this is 0, and if you solve for it, okay, do your solving, you're gonna get this right here. This solves to that, and that's our max height. So we're going to plug in negative 23.5 divided by negative 9.8, and so that's going to give us the time up to the maximum height. So 23.5 divided by 9.8, and that's going to give us our 2.4 seconds. Well, if you remember, our T max time in the previous video, our time was 2.4 seconds. Okay? Now, here's why we write the displacement formula, because we actually have to calculate, right, that time, or that position. So it's going to be y max is going to be equal to 0, because we're starting on the ground, v0 y, which is 23.5, multiplied by 2.4, minus 4.9 times 2.4 squared, and that's going to give us our maximum height of 28.2 meters. And if you remember, that was our maximum height in the previous answer, okay? Now, our total time, right? So if our Tmax time is half our total time, that means our total time is 2 times our max height time. So it's going to be 2 times 2.4, which is going to be 4.8 seconds. Again, if you look at the last video, the way we solved it, we got 4.8 as our total time. Okay? So here is part B. Here is part A. Here is part C. And now we come over here to do part D. All right, so x equals 44.1 times 4.8. Right, and that's going to give us a distance of 212 meters, which, again, if you go back to the previous video, is the same answer. So now you've been presented with both ways to do this type problem. You just need to decide which one are you going to do? Which one are you more comfortable with? Okay. Again, this is from ground to ground. It's going to be different if you have a height difference.